Hi, everybody. In lesson 4 here, we're going to continue our work with scatter plots to create linear regression equations, which is really just the line of best fit. Line of best fit. So in 8th grade, line of best fit, not line, the line of best fit. So in 8th grade, you guys would kind of sketch this by hand. We're going to let technology produce this equation for us. So in 8th grade, you were kind of just learning about how do I draw this line of best fit. Now we're going to actually have a technology in our calculator create that for us. So Kendra wondered if shoe length and the height of women were related. So those are her two variables. Remember, we're working with bivariate data here. We're not finding mean, median, IQR, or box plots of things. We're working with two variables. So to investigate, she collected data of shoe length and height for 12 women. Create a scatter plot in your calculator to determine which type of function could be used to model these data. So let's go to Desmos. I'm going to take a picture just so I have the data. And here we go. Let's go create a scatter plot. We know how to do this. So I'm going to hit plus, and I want to add in a table. And now let's see how many mistakes I can make. I'm going to type in the whole first column. 8.9, 9.6. I should have had this done already. 9.8, 10. Well, 10.0, which is the same as 10. 10.2. 10.4. I don't know why I skipped a box there. I'm just going to delete that. 10.4, 10.6, another 10.6. There we go. Making the mistakes already. Enter. See if I use my stylus, if it's better. 10.5, 10.8, 11.0, and 11.8. That was just half the data. We've got another half to go. So here we go. What are the height of these women? So 61, 61 again, 66, 64, another 64, 65, 65, 67. Whoa, careful, 67. 66, 67 again. It's a popular number. There we go. One day I'll get it right. 67. Come on, Sparky. 67, 67, and 70. Well, I don't really see anything because I've got to hit the plus sign to get to my, there's the data. So it jumped me right to my scatter plot. I'm just looking at this scatter plot. It appears to be going up across my page, so it's increasing, and it looks like I can draw a line. So I would use a linear function, and I would say there's a positive correlation between these two variables. So let's write the linear regression equation. What is the line of best fit for this data? So here's how we do that on Desmos. You're going to go to a line number 2. You're going to go to a new line, and watch what you have to type in. Notice your X column is called X1 and your Y column is called Y1. So watch what I'm going to do. I'm going to hit Y1. And now I need a little squiggle because I want it to predict it. So I'm going to hit, there's the little squiggle. On your keyboard, it's in the upper left-hand corner, but you need that little squiggle sign there. Y is kind of equal to, well, I'm going to say MX. Well, I'm not just going to say X. I'm going to say X1. Y squiggle mx1 plus b, right? Y equals mx plus b is the equation of my line. So I'm going to say y1 squiggle mx1 plus b. And what I care about here are these parameters at the bottom of the page. It gives you your m, which is your slope, and it gives you your b, which is your y-intercept. So let's write those down. Y equals, right, the equation is y equals mx plus b. 3.15, y equals mx plus, what's the b value? 32.68. 32.68. So how did I get that? I plug those numbers in for y equals mx plus b. That's your slope, and that's your y-intercept. Interpret the slope of this line in the context of the problem. So remember, last time, slope tells me, it tells us we predict y changes by the slope. Y will change by the slope for every one increase in x. So in the context of this problem, we predict height will increase by, well, what's the slope? 3.15 inches for every, well, what's x? For every 1 inch in shoe length. For every 1 additional inch in shoe length. 1 additional inch in shoe length. So we predict the height will increase by the slope. We predict y will change by the slope for every 1 increase in x. Use the equation you created. Predict the height of a woman whose shoe length is 9.2. So shoe length is 9.2. That's an x, right? X is shoe length, so I'm going to plug it in, play everyone's favorite game, and plug it in. Y equals 3.15 x plus that. Well, now I just have to type it in. So let's go to a new line here. I have 3.15. We'll try that again. 3.15 times 9.2. Wow, Desmos does not want to actually read my touching here. Plus B, 32.68. So what's our prediction? If I plug in a 9.2, the line spits out 61.66. 61.66 inches tall is our prediction. One woman in the sample had a shoe length of 9.8. There she is right there. Based on the regression line, what would you predict for her height? So we're going to plug it in again. I'm going to plug in 9.8. And remember, the line is just used to make a prediction. So let's go back and let me change that to 9.8. 63.55. I'm just making a prediction here. We predict her height will be 63.55. Is that really her height, though? No, she's really 66 inches tall. But I only predicted she would be 63.5 inches tall. So I had an underestimate here. I underestimated this woman's height. She's actually taller than our line predicts. Our line was an underestimate at that point. It's pretty close, but it's an underestimate. Let's do one more and I'll call it a lesson. So the table below shows the number of hours 10 students spend studying for a test and their scores. How many hours did you study? What did you get on the test? So I'm looking for the relationship between these values here. So let's write the regression. So how do I do that? Well, I got to get the data into Desmos if I want to create a regression. So I'm actually going to delete everything. Delete. I'm going to kind of start fresh. Clear everything out. I want a new table. I'm going to make a new regression. Now let's type in all the x numbers. Here we go. 0, 1, 2. I don't want 3. I want 4, 4, 4, 6, 6, 7, 8. Now I'm going to type in all my y values. 35, 40, 46, 65. This is such a fun process, typing all this data in. 70, 82, 88, 82. And here's our winner. They got a 95. How do I see the scatter plot? I hit the plus. So as we can see there is that positive linear trend again. A lot of the times we end up with positive linear trends. As x increases, y is also increasing. Well, how do I write the regression equation? Well, we got to y equals mx plus b. y1 squiggly, y1 squiggly, squiggly's right there, by the way, mx1, not 7, sorry, x1 plus b. Y equals mx plus b. y1 squiggle, mx1 plus b. And we get our line of best fit. And I'm going to look down here for what is m and what is b. So I'm going to write the equation y equals mx plus b. 7 point, what does it say to round to? Nearest hundredth. 7.79. Y equals mx plus, what's b? 34.27. Interpret the y-intercept in the context of this problem. Well, that's our prediction for y when x is 0. So we predict y. The test score would be, well, what do we predict it'll be? 34.27 if x is 0. If a student studies, that's x, for 0 hours. If you don't study, if there's no x, this is kind of your initial grade. You get probably a 34.27. Will you actually? Well, it could be higher, it could be lower. This is just our prediction. Interpreting the slope, that's describing the change. That's our slope right here in front of x. What's the change? So we predict the test score, what's my rate of change, will increase by 7.79 for every one more x, for every additional hour studied, for every additional hour spent studying. That's our prediction. We predict that if you study for another hour, your test score will go up by 7.79. If someone studied for 5 hours, what do we predict their test score will be? Well, 5 hours, that's x. I'm going to plug in x equals 5. So all I'm going to do is play everyone's favorite game and plug it in. We use these linear regressions here to make predictions. We use linear regressions to make predictions. So I'm just plugging in a 5. I'm going to let my calculator do all the work. 7.79 times 5, mx, 79 times 5, mx plus b, 34.27. 73.22. We predict their score will be, what do we predict it'll be? 73.22. That's our prediction. It might be higher, it might be lower, maybe it'll be spot on, but that's what we predict it'll be. Another student received an 85 on the test, so wait a minute. That's a y value they're giving us here. So we can work backwards. Let's plug 85 in for y and find how many hours did they study. So 85 equals 7.79x plus 34.27. Oh my goodness, we have to do actual algebra. It's been a while since we've done actual solving a linear, two-step linear equation. Well, here we go. We subtract over that constant. I'm going to use my calculator here just so I don't have to flip back and forth. 85 minus 34.27 gives me 50.73, 7.79x. And then I divide, and I get x by itself. So always be careful. Am I giving you x or am I giving you y? You get about 6.5. About. So if a student got an 85 on the test, I predict they would study for about 6.5 hours. That would be my guess based on this scatter plot here. If someone got an 85, that means they'd be about here at 6.5 hours studied. I'm just using that line to make a prediction, which happens to be right there. 85. Where's 85? It's about right there. It's about 6.5 hours studied. That's all I've got for this video. So the key thing I need you to understand is how do you create a linear regression? y1 squiggle, mx1 plus b. You got to use that little squiggle there to create your line of best fit. And now when you write it, you actually write y equals mx plus b. But on Desmos, you actually have to use that little squiggle there. y1 squiggle, mx1 plus b. And I'll see you guys in the last video that we have together this year. If I can end this one. There we go. Bye, guys.